So again, spring break next week. And I've been having issues with internet, like we've, mentioned. I have an appointment tomorrow to hopefully have a new internet provider. We'll see how that goes. Hopefully it goes good. Okay, and I haven't checked our schedule in a little while. Right now, we have a little more notes to do for 3.5. I have made homework. I'll put that list up soon. I'm going to wait till after break to give exam 2. I don't know if that was already the plan, but we'll make sure that we don't do a test till after break. I'll work on picking a date for the test, but right now, just want to make sure that you know we're going to have time to review and take the test when we come back from a week off. Same for the quiz. It'll probably be like last time where I make a test that's a few questions like homework, and then make a quiz about the same time as the test with, a few kind of test questions. Okay, so again, we will wait till later to do a quiz or a test, and I'll make sure that we review for both of them. Where are we? Homework. So right now, I have down that 2.7 was due last weekend. If you need more time, ask for an extension or send an email. This weekend, you have 2.8. Actually, I think I'm going to share the homework. All right, just trying to pull up WebAssign to make sure I get all of these dates right. I know which assignments we have though. So 2.8 is the end of chapter 2. We've started chapter 3. We've gotten through 3.1. We've done 3.2, 3.3, 3.4, and we're still doing 3.5 today. Okay. Almost. Still loading. Also, I know that it can be an issue having Canvas as the main place where the class meets and has all of the past meetings. And then WebAssign is where you do homework. I'm going to try to work on putting announcements or reminders about your homework in Canvas. So that way you don't get behind on any assignments that I create. So I'll try to post this up as like an announcement. And we're still waiting on the internet. Okay, while it loads, a bit about what we're doing today is the last part of section 3.5 is inverse trig. So we'll talk about some inverse trig functions and then taking their derivatives and some practice problems. Okay, if it doesn't load in just a moment, I'll maybe bring it up at the end of class. And yep, okay. We'll talk about the homework schedule at the end of class. Hopefully by then, this will be done. Yeah, I don't want to give you any false info. But right now, there is a short assignment for each of these sections, and we need to finish these notes before doing this homework. Okay. Notes. Okay. Something like sine inverse of x or cosine inverse of x. Tangent inverse of x. Yeah. Functions like this. Okay, so just to remember what these functions look like, we'll try sine inverse of x. So if f of x is sine of x. We'll draw the graph. And sine goes through the origin and completes one cycle at 2 pi. Pi. That's pi over 2. We'll also do a cycle this way to negative 2 pi. Negative pi. Negative pi over 2. So sine starts at 0, 0, and it goes up to a height of 1, down to negative 1. Keeps going. And then this way, down to negative 1, then up and up to positive 1. Like this. For sine inverse of x, we restrict the domain. So right now we're going to have this function still that we're talking about for f of x. Sine x restricts the domain. Okay, such that domain will have capital D. The domain is going to go from negative pi over 2 to pi over 2. And then the range would be negative 1 to 1. So, let's see, color. Or also you can erase a bit if you want. So we're going from here. Here. We want to graph the inverse of this function. F inverse of x is sine inverse of x. So the domain and range are going to switch. We're going to go from, let's see, negative pi over 2 to pi over 2. Okay. And from negative 1 to positive 1. Let's take a look here. All right. We have the point negative 1, negative pi over 2. They're going to come up and over like this. Let's see, double check that I'm doing this right. Cool. All right, here, dot through there, and up like that. That's the graph. Cool. We will write down what our domain and range are for this function, f inverse. Okay, this time, domain, we go negative 1 to 1. And the range is going from negative pi over 2 to pi over 2. Let's see. We want to talk about getting the derivatives, and I put you can do, well, probably more than just these two ways, but two ways you can do it is to use an identity, a trig identity, or a triangle. trig identity or triangle. I'm going to do both just to give kind of an explanation of which one, of both, but you can pick one or the other. You don't have to do both. Okay. First one, we're going to do sine inverse of x. Let me see. Cool. I put down that, well, I put y equal to sine inverse of x, which is the same thing. Okay. This is true if and only if x is equal to sine of y. Just saying, like, if you put this in here, that sine inverse and sine undo each other and leave this y sitting right there. Okay, so if x equals sine inverse of y, sorry, just sine y. Take the derivative both sides. Okay. The derivative with respect to x of x is 1. The derivative of the sine of y, where y is some function of x, is going to need the chain rule. So derivative of sine is cosine y. And because this is a function, multiplied by y prime. We have y prime equal to 1 over cosine y. And we want to go back to our variable x. So we're going to do scratch work to get what cosine of y equals. And this is where we want to talk about an identity or a triangle. You don't have to do both. I will work through. Starting with a trig identity. Okay, so we're still on the same problem. I just want to figure out what cosine of y equals. This identity, we want to try sine squared plus cosine squared equal to 1. So sine squared of y. Add cosine squared of y and equals 1. What do we have here? 1 minus, subtract sine squared of y from both sides. Let's square root both sides. And we have sine of y squared is also sine squared of y. And then remember that sine of y is equal to x. So I'm going to put this right here. We have sine y equals x. So let's have cosine of y equal to the square root of 1 minus x squared. Here, taking cosine of y. Okay, and we did all of this scratch work to go back to the derivative of that function. So it's y prime, which was 1 over the cosine of y, is 1 over root 1 minus x squared. And we'll just leave it like that. We're going to list all of these derivatives, in a moment. Okay. We're going to, we're going to go, same example. We're just going to do it again using a triangle. So okay, so we're going to draw a triangle. When I did it the first time, I put my triangle here. You can also draw it there. It's just a triangle. Just go like this. Yeah. Okay. That's your hypotenuse, H. I called this adjacent, and I called this opposite. What do I have? I put down that we're talking about sine of y equal to x. Okay. And then I wrote x over 1. And then sine is opposite over hypotenuse. Okay, my opposite side is x. My hypotenuse equals 1. And then it's the, what's it called? My mind's blanking. It's the Pythagorean theorem, where you have the sum of the sides squared. Like this, a squared plus b squared equals c squared. X squared plus, we don't know what this is. We'll call it a, is equal to the hypotenuse squared. Okay, x squared add a squared is equal to 1. A squared is equal to 1, subtract x squared. A is equal to the root of 1 minus x squared. And there would be a plus or minus sign, but you're going to use the positive square root as the side of a triangle. It's going to have positive length. Cool. Now we want cosine of y. So cosine is adjacent over hypotenuse. Okay, adjacent side is root of 1 minus x squared. You could put the hypotenuse. No, we don't really need it. And we want this part because we were figuring out what y prime was. It was 1 over cosine y. And that's cosine of y. 1 over the root of 1 subtract x. Okay, that's the end of it. So we just did sine inverse of x. We're going to write down what you have as a derivative for cosine inverse and tan inverse. And then I suggest that you memorize those ones. And then the rest of them we'll write down so that you can use them for your homework. Okay. So table or list. First one. The derivative of sine inverse of x is 1 over the root of 1 minus x squared. The derivative of cosine inverse of x equals negative 1 over the root of 1 minus x squared. All right, the derivative of tangent inverse of x this one is negative 1. Oh, nope. 1 over 1 plus x squared. All right. I would suggest memorizing these ones for, I guess, for next semester. So you're going to be taking, you're going to use these next semester in Calc 2. Cool. All right, for your homework, we have cosecant inverse of x. This equals -1 over x times the root of x squared minus 1. The derivative with respect to x of secant inverse of x. Equals 1 over x times the root of x squared minus 1. Last one. The derivative with respect to x of cotangent inverse of x. Is -1 over 1 plus x squared. That's it. Cool. So I have examples on using these derivatives until end of class. So set timer. First one, we will find the derivative of f of x equal to sine inverse of 3x squared. It's going to use the chain rule. So the derivative of the outside function, sine inverse of x, and then leave this alone. So f prime of x. So go back. So I need to memorize these two. We have 1 over the root of 1 minus our input squared, 3x squared squared. Okay. And then the chain rule, multiply by the derivative of the inside function. The derivative of 3x squared will be 6x. And then we'll just kind of write this a little nicer. So we have 6x, and it's over root 1 minus 9x to the 4th. Okay, this one we will split up into 2 pieces. Do this part first. Okay, y equal to x times tan inverse of x. Cool. Take the derivative of y with respect to x. It's going to have a product rule with this function. I'm going to call f. This part we call g. So we're going to use f prime g plus g prime f. Derivative of f. Derivative here is going to give you 1. So 1 times tan inverse x. Tan inverse x. Add. Derivative of tan inverse of x, which was 1 over 1 plus x squared. Okay, multiply by f. We'll multiply here, and then rewrite the problem. Actually, it looks pretty good how it is. Let's just flip this over, and that looks better. Okay. Okay, let y equal sine inverse of 5 to the x. Okay. All right, we have a chain rule with the outside function being sine inverse of x. Inside function is 5 to the x. So we start with the derivative of the outside, which would be, you can have notes, 1 over the root of 1 minus that guy squared. So I mentioned the chain rule. You have to take the derivative of the inside, multiply by that. So we have the derivative of 5 to the x is 5 to the x ln 5. We'll put 5 to the x times ln 5 over the root of 1 minus 5 to the 2x. Awesome. We're doing good. We're going to show that the derivative of tan inverse of x is equal to 1 over 1 plus x squared. So going back to the list of derivatives we have. And that will be the end of examples for this section. So we're going to start with writing, let's see, y equal to tan inverse of x. Okay, this is true if and only if x is equal to tangent of y. And next, take the derivative of both sides. Make sure I've got this good. Oh, cool. We have 1 equal to secant squared of y times y prime. And then solve for y prime. And we have y prime equal to 1 over secant squared of y, which we want to rewrite with the variable x. Okay, so what did I do? We got here, and I used an identity. But you can do it, other ways. This is the way I did it. I took 1 plus tangent squared of y equal to secant squared of y, and worked with that. So I want secant squared of y, which looks like I've already got. Wait, 1 plus tangent squared of y is secant squared of y, and I just wrote that tangent of y is equal to x. I have 1 plus x squared equal to secant squared of y. Yes. Y prime is equal to was 1 over secant squared y and secant squared of y is equal to 1 plus x squared. That's the end. Cool. All right, so I will be making homework for 3.5 soon. Looks like we'll be able to start 3.6 this week. And let's see. Oh, and I want to just talk about all the homework in general. So if you guys don't mind just hanging out for a moment while I put that list up. Cool. Okay, 2.8 is due. Oof. So let's see. I think I want to change some due dates. So instead of having these assignments due this weekend, it couldn't hurt to give you extra time. That means that you'll have to be doing it over break. Okay, let me think about this. Next week is break, and then you come back from break. I think I'm just gonna extend all of the homework assignments to be due like a little while after break. So I'll make those changes tonight, and we'll talk about the homework tomorrow. Okay. Thank you, everybody. Have a good day.